Today we're going to start looking at limits that involve infinity, and we're going to start off by actually doing an example numerically. We're going to look at what happens as x gets close to 2 for this function f of x equals 1 over x minus 2. And so what we're going to do is we're going to switch over to our calculator real quick so we can compute all of these outputs. All right, now that we're on our calculator, let's input the function. So we have 1 over x minus 2. Okay. And then let's go back to our main screen. And we can use this vars button so that we can pull up our function repeatedly and plug different things into it. Let me remind you what that looks like. We've done this once before. We're going to hit vars. We're going to go over to yvars. Hit enter, and then the function that we typed in is y1, so I'm going to hit enter for y1, parenthesis, and then whatever I want to plug in, and the first thing I want to plug in is 1. So that's what we get. Okay. But we're going to want to do several other calculations. Let's try 1.5 now. So y1 of 1.5, there we go, minus 2. I'm going to hit second enter again so that I can change this to 1.9. Okay. And so far it doesn't seem to be approaching anything. Let's try another one. Let's try and add another 9 here. We get minus 100. Let's add one more 9. So it seems like every time we add an extra 9 in there, we're multiplying by 10. So this thing, it appears to be continuously decreasing. Okay, and what I mean by that is, if I want to get closer to 2, I can end up with outputs that are smaller and smaller and smaller. Okay? There is no smallest output that I can get. And there's a reason for this. You can actually probably see the graph down here. You can see that as we approach x equals 2 from the left, this thing's just shooting down real quickly. Okay, and if we kept zooming out, so what we'd see is there's actually a vertical asymptote there. So let's switch back over to OneNote here. We'll fill out this table and we'll talk about some terminology. Now that we have our table all filled out, let's try and describe what's going on here in words. We say as x approaches 2 from the left, f of x decreases without bound. Okay. And the way that we write this is the limit as x approaches 2 from the left, so that part hasn't changed at all, of f of x is equal to minus infinity. Okay. And then if we were to fill out this right-hand side real quick, it would actually look pretty similar. It would be 1, 2, 10, 100, 1, oh, that's not a 100. 100 and 1,000. And in this case, we say as x approaches 2 from the right, f of x increases without bound. And the way that we'd write this is the limit as x approaches 2 from the right of f of x is equal to positive infinity. In both cases, we actually say that the limit does not exist. And let's go ahead and do a couple examples without using our calculators or graphing these things. Okay. So example 2 here. The key is to think about first the left and the right hand limits, because this says the limit as x approaches 3. So let's get that in here. We have our limit as x approaches 3 of 2 over x minus 3 squared, and this is from the, let's do from the right first. Now, there isn't really a formal way to write this, but you'll see that this way of thinking about it will make us arrive at the correct answer here. I like to just put this little square bracket here, and just note that as I am taking this limit, thinking about how the numerator and denominator are changing, well, the numerator is not changing actually at all. It's 2. But as x gets closer and closer to 3 but coming from the right, we're going to end up with some small number here being squared. Okay, so it actually isn't going to matter whether x minus 3 is positive or negative, because when we square it, it's going to become positive. But the point is it's some small number squared. So we have 2 over some small positive number. And so you could imagine this small positive number, the closer we get to 3, okay, it's getting smaller and smaller and smaller. So we have 2 over this denominator that's getting smaller and smaller and smaller. This is going to create a very large number. Okay? And in fact, this limit is infinity. Okay? This one increases without bound as we get closer and closer to 3 coming from the right. Okay. Let's try from the left. We actually already maybe caught on to what happened coming from the left. Okay. So once again, the numerator will stay as 2. And as we come from the left, this would be like a number like, say, 2.9. 2.9 minus 3 will be a small negative, but you square it, and you're going to get a small positive again. So it doesn't matter for this graph whether we're coming from the left or from the right. This limit is infinite. Even though we say it does not exist, the limit is also infinity here. Okay? And we could verify this on our calculator real quick too. Now that we're in our calculator, let's go in our y equals. We'll get rid of that function we had in there before, and we'll replace it with this new one, 2 over x minus 3 squared. And is what I'm going to do is I'm going to go into my window and I'm going to adjust that a little bit. What do we have here? Minus 10 to 10, and the point we're interested in is x equals 3. So how about we do maybe, well, actually it popped up nicely down there. I see it. I was going to adjust my windows, but you can actually probably see just looking at that picture that there is a vertical asymptote at x equals 2. And whether we're coming from the left or coming from the right, this thing is increasing without bounds. So we're going to say that that limit is infinite. Go ahead and give yourself a minute and try out parts B and C, and then we'll do those together. Let's go ahead and start on part B now, and I want us to think about the numerator first. As x approaches 1 from the right, we have essentially something like 1.1. That might be a good number to think about. So 1.1 minus 2 gives us something pretty close to minus 1. And of course it's going to get closer and closer to minus 1 the closer we let x get to 1 from the right. And then in the denominator, we have, again, maybe think about 1.1. 1.1 minus 1, that's going to be a small positive number. And if you cube it, it's going to stay positive. So we have a small positive down here. And so you have a negative over a really small positive number. This is going to become really large in the sense of it's far from 0, but it's going to be negative. Okay, so we're going to say that this limit approaches minus infinity. Let's go ahead and do C. We'll have the same deal up top here. We have about minus 1 up there. But on the bottom this time, let's maybe think about 0.9, something a little bit to the left of 1. Okay. Well, then we have a negative cubed, which is going to be a negative. So down here on the bottom, we have a small negative. And so if you have minus 1 over an extremely small negative number, and by small I mean close to 0, okay, close to 0, so that's going to give us a very large positive number. Okay, and so this limit is infinite.